Let's get started. I think people are going to trickle through as they sort of work through the technology. So hey everyone, thank you for joining our Unified Data and Analytics Databricks with Databricks Lakehouse meetup. Today it would be a Mercury story talking through the implementation and how they're using the Lakehouse platform. Now, before we get into the details, a couple of things. The NZ Data Ops, we got a couple of meetups in the next couple of weeks, but we're looking for speakers. So we're trying to make sure we have a mix of speakers across New Zealand, Australia. If anyone wants to talk about anything related to data, so it does need to have data in it, that's the main thing, please ping me on the email address below, and we can just talk about time slots and sort of dates, and yeah, we'll go from there. Now, the second meetup that we're hosting is in 2 weeks' time. It is actually the power of graph data science using Neo4j. This, we do have a data scientist who is dialing in from the UK. Well, he's actually going to be in Australia that week, and they'll be talking about how to actually build data science algorithms within graph database, which is the Neo4j solution. Will be a fairly technical session, so it won't be too high level. So I really recommend it for anyone that's a data scientist or data engineer that wants to understand more about GraphDB as a whole. Now, with that, I think what I'll do is I'll do a quick intro to for Shri Vasan and also for Chevrolet. Now, Chevrolet is from Databricks. Now, I've known Chevrolet for a couple of months now. So she's a solution architect that's predominantly focused on data and AI. She has worked with multiple startup companies and AI organizations across New Zealand, focusing on data and analytics and platforms. She is technical, so please ask her really, really hard technical questions. I would recommend that. And you can see Shrivasana nodding. And yeah, and she's worked across both Azure and AWS clouds. Srivasan, technical lead from Mercury Energy. He kind of mentioned he's only been there for two and a half years, and he's been leveraging Databricks, Apache Spark for the last two and a half years within Mercury Energy itself. He is technical too, so please ask him all the hard technical questions, not to myself, please, or to probably Jason. And the key thing is he loves watching and playing cricket as a whole. Now, with that, the way we run meetups, since it's online, is we're going to be, if you could write your questions directly in the chat at the end of these two sort of presentations. First is going to be Chevrolet talking about Databricks, then followed by Srivasan. What we'll do is at the end of each session, go through the questions. Cool. So please open the chat and type away in there. Now, with that, I'm going to hand it to you, Chevrolet.
Perfect. Thank you. Let me share my screen and bring it back. There we are. Okay. So as Akash has mentioned, I am working at Databricks, and just to introduce you, Databricks is a data and AI company. We are the inventor and pioneer of the data lakehouse, and that's why I'm here to give you a bit context of what data lakehouse is. And then Srini will take over, see how we are actually using it, implementing it in Mercury. So Databricks has actually been recognized by Gartner as a leader in database management systems and data science and machine learning platforms. So we are quite unique in that way, because Databricks started more of a data science and AI platform, but we've grown, and by now we are actually doing quite well in both areas. We are working on quite a few highly successful open source projects, so the likes of the Delta Lake that I'm going to be talking about today, also Apache Spark, that was the origins of a Databricks as such, and MLflow for people who work more on machine learning environment. We do have over 3,000 employees across the globe. We do have a team in New Zealand. It's still quite small. For now, we are just two of us, but do feel free to reach out. We are locally based. We are always happy to talk about Databricks and how could we help you. As you can see, we have quite a few logos here. We have over 7,000 customers, and we are all over different sizes, different industries. So here you can see we have McDonald's, we have Shell, So those are a bit more known companies, but we also have startups, unicorns who are only starting in their data journey, and they do find a lot of benefit from using Databricks. So when we think about the data, and it's not, I don't think I really need to sell you that saying that data is the next big thing, it's a new oil, and it is there to disrupt the industries. If you look at the companies that you see here, the likes of the Twitter, of the Google, in a way you could say that they are actually a data company, because if you think about Google, it's embedded. Without the data, Google would not really have achieved what they have achieved. So we are not really surprised that they know and embrace the data analytics and AI in their day-to-day life. But we're not the only ones. If you look at some other companies that are not our big FANG companies, they're also having success by using data and analytics. So all these companies, yet again, we are not really local, but we are quite well known. For example, if you take Regeneron, we're working on discovering new treatments for liver diseases. And by using Databricks, they managed to improve their analytic speeds by, we say, 600 times. So you can imagine what a big impact it had for their research department if they can suddenly do their analytics more than 600 times faster. If you take the likes of H&M Group, so H&M is a very big brand and it's all over the world. So all their supply chain optimization, it is a big problem. So by using Databricks, they actually had a reduction by 70% of their operational costs. And then if you take the likes of the Riot Games, so Riot Games is a gaming platform that is also not as small. As you can see, it has 77 million gamers. So not only they managed to personalize the experience, but they also were using the natural language processing to be able to filter offensive comments, because it is, you can imagine, it's not an easy problem to solve. And so they actually implemented it, and they provide a better experience for people who just want to play nicely instead of just dealing with abusive behavior. We also have the likes of the ABN AMRO. That is one of the biggest banks in Netherlands, it's the financial sectors. And as you can see here, we also have 150 ML-driven use cases that allow you to improve risk and fraud detection. So you can see AI is really helping these companies, but even though they're not as big as Google, they are using it and they are making the best out of it. And if you look at the companies like that, like there are some common points that they all have in common. And I'm going to actually touch on all four of them further along, just talk a bit more deep about what they are. At first, all of these companies, the likes of H&M and the likes of Andro, they fully embrace ML and AI as the future. So if you look at the data and AI maturity curve, it's not a very new curve, so you might have seen it before as well. Usually companies start from the, just using the data, building ad hoc reports, ad hoc queries, and seeing what happened, what happened in the past. So that's where your data warehouse report comes in, that's the usual standard BI reporting comes in. It is more of a descriptive analytics. But as the companies mature and grow, they go more on the right side. And that's where your data exploration happens, when you say, why did it happen? What will happen? How can we make it happen? So we're talking more about prescriptive analytics. And this is where AI and the machine learning sits, if you look at it that way. And it is actually really hard to add that second layer, the right side of the curve, later on. What's the difference between all those companies that are really succeeding by using AI and data, machine learning, is that they architected from beginning. So when we were doing the architecture of their data platform, they already kept the data science and machine learning in mind. So they didn't really have to re-architect and add it later on. Another thing that all of them have in common is they do use open source and open formats. As I mentioned before, Databricks is based on open source Spark project, and so we do support open source and we do believe in it, and so do the people who win with data. So why would it be important to use open source? For one, it's the breadth of the ecosystem. So when you think of open source, it has massive communities, a successful project especially. You have the universities that are teaching courses in that. You have the books that are being written about it. So it is easy to learn. It is easy to interact and gather information to see how it is all about. It is also not very nice if you are locked in some vendor. So if you're not using open source and you are logged into a selected vendor and you want to migrate, it is usually quite a costly migration project, and it's not only time, but also resources you need to put into it. But if you are working with open source system, the community usually provides the tools for that, and you have way more control for moving between. And also the learning curve, as I mentioned, there is a lot of resources. There are many people working and improving open source system. So it is usually faster to learn it, instead of if you're working with proprietary and you have to probably just go and you must take their educational courses to speed up on getting there. And actually, that's what MIT Technology Review Insight says, that if given a reader button, half of the data leaders would embrace more open source and open data formats. So even though if they haven't done that in the past, they have learned the benefit of it by now, and they would not want to repeat the same again. Another trend is a little bit more recent, is to plan for multi-cloud. So there are different reasons why organizations would like to be multi-cloud. For one, we do know that cloud is expensive. It is cheap to start with, but when you're actually using it, it is not really that, the bill is big. So if you are working with multi-clouds, you can think of the reason, you can also almost negotiate between different clouds. So saying, okay, look, if AWS is really, really expensive, maybe I can say that, well, if you don't work with me, I can go on another cloud, because my platform, my data infrastructure allows me to just pick and choose whichever I want. You can also build to the strengths of each provider, because clouds are not really equal. So some clouds are better at one part of the things and other clouds are better at others. So when you're thinking, for example, Azure, it probably would be security. They're really strong at security. Google has a lot of AI capabilities that other clouds are not really in par with. You take AWS, they are quite good at the DevOps and also the flexible tuning of the things. So it is also good to be able to mix and match of them, having a multi-cloud environment. Another thing would be external factors. So some of the customers, they might have the regulations that they have to have redundant environments, so they have to have different environments. And it also allows you to be a bit more of a future-proof, because things happen. We do have outages, and sometimes if something goes wrong with AWS or Azure, and quite a few companies or quite a few websites go down. So it would be really nice to actually be able to be more resilient to that, be more future-proof. And then the fourth, it's probably one of the more important points of what all those companies have in common, is a simple data architecture. So they all really worked very hard to eliminate complexity, because complexity always, it comes with more cost and more headache. You need to have more resources, and keeping it all in sync, it's not an easy task. So if you have a single place, suddenly now you have a single governance. So you have a single security model, you have a single lineage model. You don't really have to have 5 different governance models for your 5 different vendors if you're using, let's say, 5 in your data platform. You're also avoiding copies of the same data, because yet again, if you're using companies, the vendors who would use your proprietary data format, you would need to copy paste data all around. So if you build your data warehouse and then you want to use the same data in some machine learning vendor, you would need to copy it. So you would have copies of the same data all over the place. And it comes with the hard work to keeping it in sync. And that's just a different way to say you're trying to minimize the number of silos. So the data silos is when you're thinking about different business units, different companies having their own data. And it would be the difference of, for example, data mesh architecture, where you're actually working to share it. Silos of more if you're having the same thing in different places, possibly using slightly different rules. And that is never a great thing. So this is the things that make people successful. But honestly, most of the companies, they are actually struggling to get this right. So maybe they're good with the descriptive analytics, they are doing well with the BI reporting, but when we are going more to the data science and ML, we do know that most of the projects fail, and like we'd say the biggest percentage, they don't really even make it to production. And the question would be, why is that? What's the difference? And we say that the main pain point is that most of the time, the data infrastructure is just way too complicated. So it's actually even a simplified version of what we see over and over again if we go and talk to the bigger enterprises. So we usually start with a data lake, so where all the data is together. And then they start building on different silos. So that's yet again, you can see different silos of the data. So if you start from the left, you usually have the data warehousing, the BI solution, where you have ELT tools, so you have data warehouses. You can work with the likes of maybe Snowflake. You can maybe have something like dbt to do transformation. And you're using your SQL language and writing your BI reports. But when if a bit more complex data scenario comes in, that's where your data engineers start building something different. So we have the data engineering silo that's usually written not in SQL anymore. So it's going to be in Java. It could be in Python as well, depending on your data engineering team. So we might using something like Hadoop. We might be using Spark in this case as well. If you do have some streaming real-time use case, often it's yet another set of technologies. So that's where your Kafka would come in, or Kinesis, or maybe IoT Hub, depending on which cloud you're on. You would have a real-time database that you would try to keep in sync with your data warehouse, but often it would have different set of code that would try to perform same business logic on it. And when you have your data scientists would usually have a copy of data from all over the places. Often they would work on unstructured raw data files, and they build their machine learning models, often using notebooks. And that's where the SageMaker ML Studio would come in. They would usually work with Python, with languages like R, for example. It's also very common between the data scientists, especially around Australia and New Zealand. As you can see, you have different technology. They don't really work very well together. And so you would have, it would be really hard for the teams to work nicely together because they don't use the same tool. They don't often even code in the same language. But actually underneath, as you can see, the data we're using, it's actually the same. So all those dotted lines you can see around, it's just your same data being moved all over the place. So that just adds additional complexity. So when you look at it from that point of view, it just makes it a bit more clear that if it is structured in that way, maybe it's not that surprising that it is much harder for the data science projects to go to production. So why is it bad? Like, I mean, nobody really wants to build their infrastructure in a way that would not work for them. And actually, there is a very good reasoning for it. So when we already looked at the maturity curve, there are two different approaches to dealing with the data and all the analytics platform. So as you can see, we have warehouses, so data warehouses, and we have lakes as a data lake. And they are quite different. They are not really, we are trying to solve similar problems, but we are doing it in a very different ways. So when you look at the data lakes, they usually work in open formats because you're thinking data lakes, so it's going to be probably the Parquet file, maybe some JSON in around. And when you have warehouses, they often come in proprietary formats. So it shows you data as a table, but you don't really know what's happening between the highs. And if you do have both, you suddenly end up with two separate copies of the same data. The interface is also not compatible. So yet again, with the data lakes, we often work with Python or Java, depending on which your favorite one. But if you go to data warehouses, that's often pure SQL. You very occasionally can code in different language here. Now, the security and governance is also incompatible, because if you think about the data lakes, your data sits in files. That's often, it could be video files, it could be CSV file that would actually look like a table, but it is a file level. So your security is on file level, on maybe a S3 bucket, maybe Azure container. But if you go to data warehouse, now suddenly we have tables. So you have table access control, you have views, you have users. So it's yet again, it's a different security and governance model. And it's quite hard to keep them together. So that's where Databricks comes in. And that's where we introduce the concept of the lakehouse. So when we talk about the lakehouse, we're still talking about the data lake. So the foundation doesn't necessarily change. But when it comes with some additional features, what we call it the Delta Lake, that allows you to have the common governance and administration and allows you to reuse exactly the same data for different kind of the use cases, for different kind of the what we call personas. So it could be data engineers, it could be your BI team, it could be your data science team, all working nicely together. As you can see here, we do support all three clouds that we have around here in New Zealand. So we can work on Azure, on AWS, on Google. We do support all the data types. So that is as data lake would. So the same with the lakehouse, we do have structured, semi-structured, and structured data. And if you look a bit more deeper, the data lakehouse has the lake first approach. So that says we don't want you to have to move your data around. So all of your use cases should be able to work with the fresh data. So whatever you have, whatever your data engineers are refreshing, it should be visible in BI. It should be available for your data science team. It does have AI and ML from the ground up. So ML is very much embedded into the tool. And as I mentioned, Databricks used to be known as more of an ML platform. We have evolved since, but ML is still a very big part of what we do. And that's where we allow your machine learning engineers just make use of all the data and enable them to make things faster. We do support multi-cloud and inter-cloud capabilities. So again, we do work with all three clouds, and you can choose whichever you like best. And we do allow your different data engineering, data warehousing, data science, and real-time streaming use cases. One of the main important things in the Lakehouse is the governance. So that's where Unity Catalog comes in. Unity Catalog is part of the Databricks offering, and it provides your centralized governance and management. So it does allow you to control access on your tables and columns, so just like a data warehouse would, as well as the files and buckets as your data lake would, so you can see where it merges together. But in addition to that, you can also control access on your machine learning models that you might keep in the same platform, same as dashboards and notebooks. So you can see that we have different kind of use cases, but we have a central single place to manage the governance for that. It also comes with a really nice feature such as a data lineage or auditing. So you can always know who is reading your data or who is trying to read your data, even if they don't have access to. We are looking at things like attribute-based access control, so where you can actually define API data and manage the access to it by the label that would be attached to the data, instead of having to do it for each table separately. And we also have a data sharing. So that's where data sharing comes in, that is using open source protocol yet again. So it's not vendor locked in. You can securely share your data with other companies that are using the same open source protocol. They don't have to be Databricks users. As long as the other end supports it, you can easily share it with them. That is the Unity Catalog offering for us. If we look more on the different kind of use cases we have, so machine learning and data science workloads, they are very well embedded in the system. Do provide you end-to-end machine learn ML ops, let's say end-to-end ML ops, where you can actually build your model, you would register it, you can promote it to production. If you choose so, you can even serve it straight away from the Databricks. We're still working on improving that serving layer to be even of a high level, you can say. Everything sits still on the Delta Lake. So all the good features that Delta Lake has, the ML can use of it. So you can have an easy way to reproduce your model. If you ever had to train a model, you know how hard it is to retrain it on exactly the same data set if you are using production tables, because data might have changed since the last time you ran. Now with Delta Lake, you can rerun it on the same data. The AutoML, here we say it's for citizen data science, and it is a great thing for citizen data science because it allows you just to take a data set, and Databricks will run a couple of models on it and provide you notebooks that you can work on it. But it's also a really great tool for the data scientists who just want to fast forward their initial data exploration and just have a baseline model and work on top of it. For data scientists, we do support the notebooks, as you can see here in the image. So it's usually quite comfortable and familiar environment for the data scientists. We support Python, Java, R, and Scala, so in addition to SQL. So you can pick and choose the language of your choice, and as long as your infrastructure team is okay with that, just go and run with it. And yet again, the Delta Lake is natively supported, so you do get all those nice functionalities. For data engineering, we have quite a powerful data orchestration tool that allows you to schedule different notebooks and run them on a DAG format. We also have a Delta Live Tables, which just went to general availability last week. So it is a very, very new feature that allows you to make your data engineers' life easier, basically. So your data engineers here would focus more on the business rules, on what the transformations need to be done, and way less on the infrastructure, because the Databricks Delta Live Tables way, it would actually have a very resilient auto-scaling the environment for you that just runs. And you need to focus more on what actually business rules are on the data that you're working on. For the SQL workloads, so we do have a great performance on BI and SQL workloads. Yet again, you're working on the same data lake. So whatever data engineers are working on, you don't really need to copy and move your data somewhere else. You can work there straight away. You can see in the GIF, we do have a SQL interface where you can just write your SQL queries, get the visualization straight away. But we also support a native integration with the BI tools. So if you do use Power BI or Looker or Tableau or the likes, it's very easy to connect it straight to your Delta Lake and build your more advanced visualizations using those kind of tools. So this is all the main features of what Databricks offers. And I was like, how did we actually achieve it? How did we manage to take what's the best from data warehouse, data lake, and come up with that lakehouse? So if we focus first on the data lakes and see how they actually work. So usually you start with a data lake that holds all your data. So it has structured, semi-structured, and unstructured of the data. It's great to start with, but it usually comes with some of the issues. First one would be reliability and quality. If you work with a data lake, like a pure data lake and the Parquet files, you know how hard it is to keep it reliably up. Because you do have like sort of like schema on read. It sounds really great when you start with, but when as soon as you upload the wrong file in the wrong location and suddenly all your data is corrupt and can't be read, you see that it is not great. If your ETL job fails midway while processing like a couple of gigabyte size of a file, your data might be corrupt. And unless you have a really good monitoring on top of it, you're probably not going to know it up until some time passes, and then you're going to have to rerun all the jobs later. It is hard to keep it reliable and of a good quality. But even if you do manage that, the performance usually is not great if you're working with just pure data lakes. So you might have different issues like many small files. So if you have some IoT device that streams to your data lake, your file size is minuscule. So if you want to look for some kind of the data, you need to open all the files, read them, and even if there is no data that you look for in there, just close them and move on. Or if you have really massive data files, it also causes performance issue. But let's say you actually you put lots of work into it and your performance is workable with. Even then, security might be a problem because yet again, we're talking on the cloud level, on the data security. So usually when you come to that, it's often all or nothing. So you grant access by S3 bucket or some storage account. You might try to split your data for different teams to have access just to specific storage account. It does get really complicated. Then if you take traditional data warehouse workloads, if you try to run some BI reports on top of it, it's gonna struggle. It's not gonna be great performant. If you are trying to, if you're trying to do the data sharing, it's also quite hard to share it securely because now you have files being moved. If you want to share your data with some different organizations securely, it's an issue. If you want to share your data with your different business unit, maybe also securely, you have to come up with a process. It's often quite challenging. So that's where the Delta Lake comes in. And Delta Lakes provide solution to all of these things. So for reliability, we do have asset transactions. The asset transactions that makes, if you look at it from very high level, it makes sure that your transaction all fully successful or completely failed and it's rolled over. So you don't have data corruption that just failed in the middle. It comes also with the time traveling that allows you to see what your data was like, maybe let's say at noon yesterday, or if you by accident delete something that shouldn't have deleted. So what it was just before you delete, then you can easily get your data back. When you talk about performance, we have put a lot of work in it for advanced indexing, caching, and auto-tuning. And actually, late last year, we even won benchmarking for the data warehousing just for performance, for using all these new features that we added into Databricks to ensure that Delta Lake is performant lake. Now for security, that's where Unity Catalog comes in, as we talked about. So you have fine-grained role-based access control that can be on your table level as well. So we do support groups, so it doesn't have to be on user level, but you have actually very granular control on your data. Now, in addition to traditional data workloads on Delta Lake, you can actually run analytics, you can run your machine learning, you can run streaming, batch, all the things we've seen just before, all the different kind of use cases, different kind of personas, they're fully supported on the Delta Lake. And if you do want to share your data, we do use open data sharing protocol that is part of Unity Catalog, and it allows you to share your data securely with the other company. But yet again, they don't have to be Databricks users. They only need to support that open source data sharing protocol. So yeah, so as you can see, Databricks and the Lakehouse enables you to just make the best of your data platform. And here I'm going to pass to Srini to tell you how actually Mercury, it's our local New Zealand client, and how we used the Lakehouse, how we implemented it internally. Stop sharing.
Thanks, Shirley. Thank you for that. If I'll probably give a few seconds for anybody to ask questions to Shirley. If not, I will start speaking. I like how you guys are saving up all those questions for me. Nice. All right. Good evening. Thanks a lot for joining us. Before I begin, I would like to say I'm impressed with this crowd. Late in the day, especially for New Zealand, at least 30 people showing up to talk about lake houses. Love this crowd. My name is Srini, and I'm part of Mercury's data and analytics team. I am primarily responsible for solution architecture and scaling our data engineering practice. I can keep speaking about myself, but you guys are not here to talk about me. So what I'm going to do is give you a quick introduction of what the business is about, what Mercury is, and then how our data landscape is was set up, and how we improved it with the Lakehouse architecture. Most of you might know Mercury as an energy company. We are a gentailer, meaning that we generate electricity and we sell electricity. It's a nice word to say that we do both, really. And all of our generation of electricity comes from 100% renewable resources, and that's something that we're really proud of with hydro, geothermal, and wind. We've got 14 stations that is producing this electricity for capacity for us. As we speak, we are expanding a new wind farm. We have already started producing some electricity from it, but we keep scaling. We will keep scaling in the future. We are an Australia and a New Zealand listed company with close to 800 plus team members. That number has changed because of the recent changes. It's gone up, which is a good thing. It's a nice sizable company. What I love about Mercury is how diverse the data landscape is. Now, because we generate electricity, you can imagine the types of data we have. We will have assets, physical assets that produce electricity to manage that. We will have data coming in from IoT sensors that talks about dam states, river state, whether it is operating or not, what is the water level at each of the station, etc. And on the other side of the spectrum, because we sell electricity to customers, we have customer master data, we have metering to understand the usage of electricity across the premises, and everything in between. So if you like working on data, Mercury is a great place because you get access to all of those data points. With that diverse landscape, the way we are set up today is diverse as well, right? So in this image, you can see 3 business units. Wholesale markets is basically tied to generation business unit where we produce electricity. Retail is basically tied to customers where we retail electricity and manage customer interactions. Finance basically overlaps generation and retail. As you can see from this picture, without naming technologies, you can see that we use different technologies for different business units. And there are multiple stakeholders working on each of those data sets and technologies to primarily data discovery and reporting. So we have a bunch of stakeholders who have reporting in their title, whose main job is to understand the data coming in and make decisions based on that data. Right? So when we sat down and looked at the landscape, we have some of the drivers that we had were mostly from retail business because they had business cases that were quickly achievable and were more relevant to improving customer stickiness and improving our business, like understanding how loyal is a customer to Mercury in terms of their lifetime value. Are they going to churn quickly? And a topic around personalization. How can we give personalized offerings to customer to improve stickiness and serve them better? On the generation side, there were a lot of use cases that were very heavy on data. For example, creating a digital twin of the whole river flow on which we produce hydroelectricity. How do we manage the assets that produce the electricity? How do we understand and forecast the demand for electricity? Because Electricity Authority asks every generation company to produce a certain amount of electricity based on New Zealand's requirement. So how do we forecast it and how do we use our renewable resources efficiently instead of underutilizing them, overutilizing them? So these use cases are heavy on data, and without having a proper data platform foundations that enables all of this, it's difficult for us to start. And we spoke about the different types of data we have in Mercury. We've got fast data coming from SCADA, or we got fast data coming from metering as you keep using the electricity. We've got data from external parties, and we got certain data sets that are specific to the industry. Like in our geothermal plants, when we drill holes to produce electricity, that produces geographical and chemical data, which I have never seen outside of Mercury anywhere, to be honest. So, and that's really interesting to play around with. So we've got enough enough drive to create a data and analytics platform, a modern platform that does data science and machine learning and all that. Then there were needs, right? However, with the solutions that we had certain limitations. For example, all of these technologies were imported to the cloud, right? They were not built for cloud, which means we were not able to take advantage of the elasticity that the cloud offers or managed services that the cloud offers. And from the image, you can see that there is a high amount of redundancy / data silo across the things. And because we use different technologies for different business units, we had to move the data across. And as everybody knows, when we move data, we are making the operation expensive in terms of time to move the data and also in terms of quality. Now the same data sits in multiple places and you have to manage quality in all the places where it sits. And when you do that, indirectly, what happens is data follows compute. A technology sitting for one business unit cannot go into the tech sitting with other business unit to read the data. It needs data within its own servers to understand and process the data. That's what we mean by data follows compute. So you have to move the data to a particular technology to work on it, right? Which means data and compute are tightly coupled, which, as you guys know, is not a great thing to have. And in the current landscape, there was no clear path to advanced analytics. Some of the use cases that we have, if you read the bullet points on top, like for example, digital twin or forecasting or propensity of a customer churning from Mercury, we need feature engineering, we need machine learning to be implemented, but the current landscape did not have a roadmap for that. So when we set out to build a data platform to solve all of that, we came up with certain drivers, which was basically recapping from the previous slides. We wanted to eliminate data silo for obvious reasons. We didn't want data everywhere and we were managing the data everywhere. We wanted the data assets to be in an open format. To Jivilay's point, having the data in open format allows you to work with it easily in terms of technology integrations, as well as it gives us the ability to change technology in the future if we need to. Not that we will, but it's good to have the ability to change technologies and put multiple technologies on the same data without moving your data asset. Separation of data and compute is critical because we need the ability to scale compute irrespective of data, and we don't want it to be coupled because we don't want to keep carrying it across different business units. Number 4 is every architect's dream. We want a simple data landscape that can do everything, right? And that was one of our drivers as well. Enabling advanced analytics was a no-brainer because of the use cases we had needed feature engineering, machine learning, and MLOps really. And 6th point, this is in no order of priority. 6 actually should have been number 1 because we wanted to get the data to the stakeholders who want to look at the data, as opposed to them raising a ticket to IT to get to a data set. That's not what we want. We wanted people to get to the data assets by themselves, explore the data, discover the data, and then find insights themselves, and then even create data assets. So promoting self-service culture in terms of data analysis or data engineering or even data science was one of the drivers that we had. Right. So when we set out to build a data platform, we did not want to create a Lakehouse platform. That was not the intention. We started creating a platform based on this, and then it just aligned with the needs that were satisfied by the Lakehouse architecture. So that is our data platform. So let me do that slowly. We've got data coming in from sensors and digital meterings and all that. I have classified that as a fast data capture. So these are data points that are coming in every 5 seconds, or it comes in when a customer calls us, right? It's either event-based or it's a streaming data that comes in like frequently. And then we've got slow data capture. By slow, I mean it's not really slow. It could be micro batch even every 1 minute or every intraday or once a month. So these are your loyalty and marketing data, customer master data, asset master data, and generation data. Really. So these are the different data sources we deal with. And what we do is when we source data from all of these data points and store them in a landing location, which is really an S3 bucket, and we call it staging. When we are ready to deal with it, we ingest the data into a raw layer. Right? When we ingest the data into a raw layer, if there is sensitive information or personal information around it, like a customer name, we actually separate it from the actual data point and put it into an area called raw restricted over there. Right? So what happens is when a user comes onto the data platform, they by default go to raw and not to raw restricted, and that's by design. And we only open up that for people who really want to look at customer names for some reason. When we are ready, and for all intents and purposes, this raw layer is the data lake of the data platform, because it's going to have data which is true to the data source, and it will have all the history appended. So it'll always be there. It'll always have all the history, which is really the purpose of a data lake, really. So that's the data lake layer of the platform. When we are ready to understand how the data is going to be used, then we start applying transformations to it. We start blending multiple data sets into one, and then we start giving nice business names and definitions and write a business glossary and all that and store it into the model layer. Model layer is the business data layer. When a business user or an end user wants to look at the data, that's where they go to, because it's prepared in a nice format. It has nice business names to it, and it's easily understandable. Now, the raw layer and the model layer are managed as Delta Lake tables for us, right? So if you consider raw as the data lake, and if you consider model as the data warehouse, we have effectively managed to put that into one technology, which is the Delta Lake from Databricks, as Julie was explaining. If we didn't have that, what we would have done is probably used a file system like HDFS for raw, for data lake, and then we'll have a Redshift or a data warehouse, any other data warehouse solution for model, and you will have two different computes there, which is against what we wanted to do. And then in the data engineering, we have a pipeline to manage data quality across these layers, right? Now, all of our data engineering programs, like these functions like sourcing, ingestion, modeling, which is transformation, and managing of quality, is heavily templatized, meaning that all of these are given to engineers as pre-written services. So they basically import the service code and use it in their pipeline. What makes them reusable are basically configurations or metadata, as we want to call it, which is managed in a relational database on an RDS system. So that's how we get the data in. That's how we manage the data. And if you see, go from staging to raw to modeled, as you go below, go from staging to raw to modeled, the level of data maturity increases, the data quality increases, the usefulness of the data improves, right? Staging is probably a transient area, which is purged after a while, but raw is never purged and it's always there. So is modeled. Right? So now with this data platform, we see three main patterns of consumption. The first consumption pattern is understanding what data is on the platform with data discovery and visualization, right? Today, predominantly, most of the discovery and visualization happens on Databricks Notebook. But as we speak, my team is implementing a connectivity to Power BI in order for somebody to log into Power BI and query the data that we have here in the model layer. In theory, people could go into raw, but then that doesn't have business names. But by default, we've made it that you will log into Power BI, you'll be able to go through a Databricks compute into this model layer where they can then play around with the data. So that's the first use case. The second consumption pattern is advanced analytics, right? Then this is, if you go back to the needs, this is one of the reasons we wanted to create a data platform. And as it stands today, we do feature engineering and model training and model scoring with Databricks notebooks, which will be served as an outcome to a web application or a third-party system as an embedded analytical model, right? Third consumption is really data serving. Now, there will be cases where we don't need to discover data, or we don't need to do advanced analytics on it. All we need to do is prepare data and send it out to a third-party system or a user interface for them to use it. And we have two ways of doing that. We either have a Databricks process that serves the data as a physical data asset, as a temporary mechanism, or we have a data service as an API endpoint where applications can hook onto an API endpoint and we serve the data over an API endpoint, right? Now, all of this is supported with Databricks compute. The compute comes from AWS EC2 really, but managed with Databricks, so we don't have to deal with the cloud. Okay. If you look at the right side, the three consumption patterns that I'm talking about, all of it goes back to one layer, which is the Delta Lake layer, which is managed as one data storage mechanism. So that's the data platform that we have in Mercury. As I said, we didn't set out to build a Lakehouse architecture. We had needs, and then we were working backwards from the needs to understand how to create a platform to address those needs. And the concepts that the Lakehouse paradigm gives us fits nicely into solving each of these, right? Now, if you play back against the needs that we have, against what we have achieved here, the first one was, if you remember, we wanted to reduce or eliminate data silo, right? And data to be open. Now, given that all of the data is here, be it the data lake or the true raw layer, which is predominantly used by machine learning for training their models, or modeled data, which is used for business self-service and discovery, or feature engineering outcomes or model inferences that are stored back, it's all managed within Delta Lake technology, right? So for everything that happens on the data platform, we don't need to go to a Redshift for data warehouse or a HDFS for data lake. We have managed to put all of that into nice storage, which is Delta Lake. The data that Delta Lake manages is in Parquet form, right? Parquet is an open format standard, and we have proven multiple times that if we decide to change tech for any reason, any tech that can support Parquet can work on this data. Even if I'm not saying we will, but even if we move away from Databricks, that data asset we have produced from day one is still usable as an asset to Mercury, which is an important thing, and we have achieved that. So that's one of the needs we had, which we have achieved with the platform. The other need was to separate data from compute. Now, as you can see, the compute is separate from the storage. Data engineering needs medium 4 CPU, 8 GB memory cluster or a machine to run its processes. An analyst self-service or a discovery probably needs less than that, but it needs to be always on 24/7 because Power BI should be connecting to it to refresh the dashboard real time. Data science probably needs a memory heavy compute or a machine because it trains data across last 5 years or 10 years. And data serving is also a very lean cluster that needs probably less CPU and less memory. So each of these processes have different compute requirements, meaning we have different Databricks compute or clusters or endpoints that is being given to each of these processes, but all of those compute work on the same data storage. So by implementing that, we have managed to keep data in one place, and we are able to bring different computes to the data depending on the workload we choose. And that's how we've proven that we don't need to have data and compute tied together. We can separate them. We have simplified the landscape. I'm really excited about this because when I sit down and try to architect a system, if it has less number of moving parts, then you've won, really, right? So data engineering today predominantly happens in using PySpark on Databricks. Machine learning happens a little bit on Pandas and Spark ML on Databricks as well. Now, analytics self-service happens as Databricks notebooks today, but we'll be moving to the Databricks SQL workspace very soon. And the data serving part, which is pushing the data out, we have not embraced data sharing yet, but we've managed to create a Databricks process that moves data as we need it. So for all of these different workloads, we basically work on the same tech, simplifying the landscape and simplifying security. The fifth one we wanted to do was enable advanced analytics, predominantly around feature engineering and machine learning. We have got strong foundations there in terms of data science processes, in terms of CI/CD for data science processes. But one area where we would need to ramp up on is the use of feature store as a service from Databricks, and as well as using the model registry offered by Databricks to better implement an MLOps model. Today, the machine learning happens like an engineering pipeline. You develop something, you test something, and you deploy it. But everybody knows that machine learning cannot work like an engineering pipeline. So it needs its own pipeline. So that's why we have to embrace the concept of ML ops and having a centralized model report to deploy your models all to one place. So that's the next step for us. And some of the projects in flight is actually demanding us to go there faster than we thought we would. But we've got the foundations. We just have to make the next move to it. And in terms of promoting self-service culture, as I mentioned, analysts today log on to Databricks to work on notebooks, but what we really want to be doing is promoting the use of Databricks SQL Workspace, starting by introducing SQL endpoints for Power BI users so that they can go through an endpoint that is much faster than a regular compute, and then slowly embrace the use of whole Databricks SQL. Now, when we talk about self-service, I mentioned that we want to get the data to the people who want it as opposed to waiting in queue. Now, when we want to do that, we still want to have a little bit of, not a little bit, a good amount of governance to it, while giving the freedom to the analyst to work on the data sets and build data sets for their consumption. We also want to make sure that we govern that properly. And that is an investment in the area of Unity Catalog, which Databricks is doing. So when we are ready to do that, all of the metadata management, the lineage, and the access controls that we have in place will be managed by Unity Catalog. So enabling advanced analytics and self-service is our focus in the next half of this year and onward. Right. So that is how the platform is set up, and that's how we have achieved the goals. Even though it's not a perfect platform, it doesn't perfectly align to a reference architecture. If you go to Google and search for a Lakehouse architecture, but that's okay. We accept that. And this works beautifully for Mercury because we've got all the foundations right. We just have to keep building new blocks to it and expanding it as we go along. Now, before I wrap up, I would like to finish by showing you how we have managed to deliver certain initiatives on this platform with this architecture. Right now, one of the initiative is already in production, and one of them is actually in flight. I would love to show you how it works and show you cool screenshots, but I'll do the next best thing, which is to show you some diagrams. Yeah. So this is a retail use case for us. This is predominantly around personalization, automating the marketing communication sent to a user. A very simple example is when a new user sign-ups for Mercury Power, we basically capture that as an event, and then we run it through the data engineering pipeline, and then we source it, ingest it into raw, and all of their personal information goes into raw restricted, and then we model the data. We model it in such a way that that modeled entity has customers' information, their profile, their meter usage, things like if they're a new user, they captures around demographics and all that. And that modeled information in a nice form is delivered for analysts to log on and explore the data. A version of that is also sent out via the outbound interface to a marketing or a campaign application that triggers emails and campaigns based on the data we've received. Going back to my example, when a new user signs up, we understand that it's a new user, and then we add it to an existing table, and that sends a trigger to our campaign tool, and basically it sends a welcome email to the customer. And that's a simple example, and we have more complex use cases of that, wherein that pipeline also suggests what is the next best action for you. Oh, you're almost there for your bill period. You have to pay for your bills, or do you want to try other products? So sending out personalized comms and automating the marketing communications. So that's something that we've delivered. And if you see, it uses most parts of the pipeline, and there's no real feature engineering or machine learning happening there yet, but we are expanding there. Some of the projects we have in pipeline will basically cover those areas as well. So that's a retail use case. On the generation side, now this is something that I'm working really closely on, and it's a very cool use case. It's a pity I can't share more than that. But at a very high level, without going out into detail, this use case will give hydro controllers. Sorry if you can't see that. This will give a data-driven plan to a hydro controller to make decisions on how to dispatch electricity in an efficient manner from our power stations, while making sure that we don't underuse or overuse our resources. At the same time, we don't end up spending a lot of money. So this is real-time streaming. We got fast data coming from IoT sensors and some master data coming into our pipeline. And we have a machine learning model that is running probably every half an hour, trying to train and give out recommendations to a third-party system that is embedded as an outcome. So this particular use case has stretched our architecture to say that you also need to serve the data over an API endpoint. You can't just keep pushing the data. The data will still be locked in here, but it will be served over an API endpoint. And applications on the right side, like Akash spoke about Graph. Graph is one of the users of this API in future. A Graph system will basically grab the data from Delta Lake over a served API endpoint, and there will be a user interface where people will be logging and clicking and pointing things, which also sends the data and data back and forth through Databricks compute. So this covers our data engineering, this covers machine learning, this covers data serving. Basically, it uses all the parts of the architecture that we have designed for. With that, I will call it a close, and then lights have come up, and then I'll take up any questions. I hope I was not on mute the whole time. You guys heard everything?
We heard everything, Sri. That was a very good presentation. Maybe I can quickly start with a question from my end. So just the reason why you didn't go for the gold, bronze, silver architecture from the lake design, was there like benefits for reducing that, I guess, the zones?
Well, that's, yeah. So the staging raw model that we have is same as bronze, silver, and gold. Staging is our bronze, raw is the silver, and model is the gold. We just call it different names, that's it. But we do have that layered data architecture in place.
Got it. Okay, cool. Makes sense. Thank you. Any questions, audience?
Yeah, I have one. Radek here. Hello.
Hello again, Radek. How are you?
Hi, Srini. Very good presentation as usual. I'm impressed. Oh, actually, I'm not impressed. It lived up to expectation. I actually got a question for Zavila. So at the beginning, you talked about the multi-cloud, which is very topical at the moment. So isn't there a bit of a contradiction between saying you should do multi-cloud and between having everything in one place with like one governance, one set of processes, etc.? Like, how would you deploy stuff across multiple clouds with Databricks?
So that's actually one of the benefits. So you would still have, okay, for the first, currently it's not available yet. It's our stretch goal. We want it to be almost invisible. So you could choose whichever compute you want, whichever storage you want, but Databricks on the top, where with unification happens. Your data platform still sits on Databricks, your Delta Lakehouse still in one place. So you still can manage your governance security. But if something were to happen, you could possibly switch out EC2 with the Azure VM. That's where that comes in.
Okay, so it would be on a workspace level or even on an individual cluster level, you could pick where it's sitting?
Oh, it's way too soon to say, because as I told you, currently it's not available. It's just our goal. So we want it to be possible in the future. So possibly, maybe, it could be on a cluster level.
Okay, thank you.
For now, I am just speculating. I don't have an answer to that.
Cool. Thanks. I'll let someone else ask a question.
There's a question in the chat. What has been the biggest learning since using Databricks, and is staging used mainly for hot data transforming formats?
Right. Okay, there are two questions. The biggest learnings for Databricks from Mercury's perspective is that one, it has with the recent introductions and the use of Databricks, it has reaffirmed our choice of technology, mainly around unification of workloads, as I was talking about, as well as future investments around enabling analysts work on the data platform as opposed to just engineering tech users. It's also allowing end users to work on the same platform, plus the investment in governance around Unity Catalog. So when we assessed the platform, we already knew it was capable of doing machine learning and engineering fantastically well. That's okay. But improving the game around onboarding analysts and then having a governance support in the form of Unity Catalog was a game changer for us. And that solidified our investment in Databricks. So that's what we've liked about Databricks. That's what we have learned. In terms of using the staging layer, staging is really transient, right? When we are talking about streaming data and batch data, for batch data, it is more around a transient layer, and which just goes down to raw and then model eventually, and then it gets purged after a while, or it gets tiered, not purged, it gets tiered to glacier and then it gets deleted after. That's for batch. But for streaming, we go from stream directly into one of our layers, which is a pattern that we are working on right now. So if an IoT sensor is producing data every 5 seconds, we capture it in a Kafka or a Kinesis stream, and then we process it and then land it into ingestion. So the Kinesis or Kafka technology becomes sort of our staging layer, right? At that point, you don't have to stage as a batch file. So the hot data goes on for streaming use cases, goes on to streaming technologies. For batch, the staging is the landing area. 3 seconds of silence means the answer is accepted. Okay.
Cool. Thanks for that. That's really good presentation.
Thanks, Greg. Clement has a question. What strategies do you use for ensuring data quality? Very good question. Not as much as we would like. Some of the strategies we use at a high level, we have completeness, like making sure that whatever we have sourced is whatever we have ingested, which is basically doing a select star on, loosely speaking, doing a select of count star on both sides. That's completeness example, and then schema validations, and then schema integrity and data integrity are all those things. But today we don't have a data quality pipeline. When we model data, when there are pipelines to be delivered to use cases, we do quality based on specific use cases. Where we need to improve our game is around having a data quality pipeline that identifies if a schema has changed or identifies if we have gone over the threshold of number of nulls allowed and things like that, proactively checking for quality defects and either stopping the pipeline or raising an alert. We don't have that yet. But what do we have? What we have is before we deliver a use case, we do some quality testing at the end of the pipeline, not when sourcing it. We would like to move the quality upstream as opposed to waiting until the data is modeled. So yeah, in terms of strategies, we use completeness, data integrity, and schema validation at a very high level.
Any other questions? Maybe a quick question from me. Third normal form, do you guys have any practices around deduplication, or do you just bypass that whole process?
Somewhere in between. So we have a strict policy of not adhering to a specific modeling methodology. So we used to arm wrestle about Ralph Kimball versus Bill Inmon model 7 years ago when I was still working on data warehouses. But here we don't follow either data vault or we don't have a specific snowflake or a star snowflake in terms of dimensional modeling snowflake. So we don't have a strict adherence. The one standard we have is we model by demand. So we don't create transformations by default. When we get the data from staging to raw, we stop there. Only when we know how the data is to be used, we then model it based on that use case, of course, to answer that use case and a few other things. And we model it in such a way that, of course, there are no deduplication, but we don't try to create an OLTP like third normal form things. So if you look at, if you're allowed to, and then if you look at some of the diagrams, that design diagrams that we have, you will have a mix of both. In some cases, we accept duplication because it helps with the performance because those are pre-calculated. In some cases, we go for strict no duplication. So without having a use case, I will not be able to answer that. And within the boundaries of what I'm allowed to say, that's all I can say.
Yeah. There's another question in chat.
Yeah, I didn't want to interrupt. I'm happy to repeat it. But basically, when I look at Trini's beautiful diagram, right, like, and when I see what other companies are solving this, whether you call it gold, bronze, star, or raw, modeled, etc., there's lots of similar problems companies have to solve. And it seems to me like you always have to, every company has to solve it for themselves, but they're solving a very similar thing. So is there some kind of out-of-the-box template, content pack, automation solution if, for example, I didn't want to hire a team of Python developers to code all the pipelines?
There are different approaches to that. We do have something called solution accelerator that is something like what you're talking about. It's templated, but much more oriented for the data science and machine learning solutions, less of the data engineering. For the data engineering, likes of the Delta live tables they simplify it a lot. So it doesn't come with a template as such, but it allows you to define the rules, and it's more of a SQL only base, so it's simpler. You don't really need to write complex code to achieve the same outcome. But as far as templates go, automated solutions, Solution Accelerator is a good thing, but as I mentioned, it's mostly focused on solving business problems from a data science point of view. So you can have things like a fraud detection or maybe churn prediction, things like that. So for those, we do have data engineering, not so much.
Thank you. Live tables just went live recently, right?
Last week.
Cool. Nice.
Hey, any last question and we can wrap up? Okay, maybe question for you, Javel, is if anyone wanted to actually understand more, what do they do? Who do they contact?
Feel to reach out to me via LinkedIn, or you can just email jivile@databricks.com. ZIVILE, and we can definitely talk.
Perfect. So guys, that was a really good presentation. It really demystified for me what Lakehouse was and put a real life use case around it. So thank you, Databricks, and thank you, Mercury Energy, and especially Shri and Javel for going through this. What I will do is questions around the presentation pack. I'll work through all the logistics, send it through the Meetup website.